Before we leave the topic of lines of symmetry entirely, let's look at three other common shapes and try to figure out how many lines of symmetry they have. And here we've got ourselves a square, okay, that's this shape, a rectangle, and a circle. So let's start with the rectangle. We actually did look at lines of symmetry once with rectangles. Let's do it again. Try to recall what we do to try to figure out if there's a line of symmetry. We could either flip the object over along a line, or we could fold it along a line. Okay, so let's take a look at how we could fold a rectangle so it could go right and fold right onto itself. So one way we could do it is this. We can fold it in half lengthwise. And if we line it up just right, and we flatten our crease here, we take a look at what we've done. We've basically folded our rectangle in half lengthwise, and we've got a line of symmetry because this side fits right over this side like pages in a book. So let's go ahead and let's mark that line of symmetry. Okay, so we've got a line of symmetry like that. And can you think of another way to fold a rectangle that might give us another symmetrical folding? Well, if you are thinking along the diagonal, that's not going to work, right? If we try folding it along a diagonal here, we go from one diagonal to another. Let's just see what happens. We fold it from one diagonal to another. Doesn't really look too good, right? We're not folding it on top of itself. It's not overlapping on itself. So the diagonals don't work for a rectangle. So that's not a line of symmetry. But what about folding it downward along the width like this? Will that work? And it will. Okay, if we do it just right, we fold it just perfectly like so, we will have the rectangle on top of itself in this direction. So we've got another line of symmetry, which is sort of this horizontal line we just created. So let's draw that one in. Okay, and there we've got, you can really take too well. Okay, so there we've got our two lines of symmetry. Actually, that's all a rectangle has. If its opposite sides are equal, but adjacent sides are not equal. So in this case, we have a rectangle. These two sides are shorter than these two sides, and all we've got are two lines of symmetry. We cannot find another line that we can fold the rectangle that will have the rectangle overlap on itself. But let's go to a square. And a square is a little bit different. Okay, so we've got the same two lines of symmetry with a square that we have with the rectangle. We can fold it like the pages in a book, creating a vertical crease, like such, and that will be one line of symmetry. Okay. I can now fold it downward like I did with the rectangle, and that would form another line of symmetry. Let me draw that one in. Okay, good. So now we've got our two lines of symmetry, but there are two other lines of symmetry that a square has that a rectangle doesn't have. Can you see what that might be? Okay, so we can fold this corner down to this corner, which is something we try to do with the rectangle. We try to fold along the diagonal. It did not work with a rectangle, but it will work with a square. So because all four sides are equal, we could join two opposite corners to each other just like that, and probably didn't fold it quite perfectly, but it will fold over, and we have ourselves a line of reflection that is along the diagonal here. So we can draw that line of reflection in. Okay, and then we can join the other two corners. We can take the upper left to the lower right corner, and that will also fold over. So that gives us our fourth line of symmetry. So again, we have this. We can open this up, and we've got our fourth line of symmetry. So a square has 4 lines of symmetry, unlike a rectangle, which only has 2. Okay, sorry for tearing the paper a little bit there, but those are the lines of symmetry of a square. And now finally, let's take a look at a circle. And how many lines can we fold a circle onto itself with? So let's start doing that. Let's fold a circle onto itself. It's actually pretty easy to fold a circle onto itself, right? All we have to do is fold it in half, and we get a line. There's our first line. Good for us. Let's draw that line in. Let's fold the circle over again. Anywhere, anyhow we want, as long as we use a different line. Let's fold it over like this. And open it up, and we've got another line of symmetry. How many ways can we do this with a circle? Well, we can fold the circle anywhere we want, can't we? I mean, I can fold it like this if I want. I can fold it like this if I want. I can fold it like this if I want. And I can keep on choosing different lines of symmetry all along. So let me go ahead and just fold it in half like this. And I've got another line of symmetry. I hope you're getting the idea here that no matter how I fold the circle, I'm going to create a new line of symmetry. In fact, since I can fold a circle in an infinite number of ways, a circle actually has an infinite number of lines of symmetry. Okay, no matter what point I pick along the circumference, if I pick this point here and I fold along that point, I could choose any point, fold along it. I've just created myself another line of symmetry. Okay, right where I had that point. And so on and so on. So this is yet another line of symmetry I just created. I can fill that one in too. Okay, so I hope you get the idea that since I can fold the circle in half an infinite number of ways, there's really an infinite number of lines of symmetry in a circle.